Okay, so this video is on the aromatic compounds. It's the second video for this topic and the last, and it's on benzene reactions. So benzene's reaction mechanism is electrophilic substitution. It does this because the high electron density of the delocalized rings attracts electrophiles, and in case you forgot what these are lone pair acceptors. It doesn't do electrophilic addition reactions, and this is because this will withdraw electron density away from the delocalized rings, and this will reduce the benzene stability, which we never want to do. Nitration is one of the types of electrophilic substitution reactions, and this forms nitrobenzene. These are used in dyes and TNT. The reagent for this is NO2+, and the condition is 60 degrees Celsius. To form the reagent, unfortunately we need to know one of these equations, but it's not that hard. We just react the nitric acid with sulfuric acid in a reversible reaction to form nitrogen dioxide, hydrogen sulfate, and water. Just make sure that you can realise that there's actually a minus charge there. So sulfuric acid in this reaction is reformed, and instead of just reading this out to you, I'll kind of explain the reaction and show you at the end. So this is the reaction mechanism, the electrophilic substitution reaction for nitration. You need to make sure that your arrow comes from the delocalized ring. If it comes from inside, it's wrong. If it comes from in the middle, it's wrong. It has to come from the ring. Okay, so now that you know where that needs to come from, in the next step, once you've attacked your electrophile, well, you need to make sure that you have a crescent inside your benzene, and these need to be up to, not before and not after, the adjacent carbons in the benzene. If you did it here, it's wrong. If you did it there, it's wrong. If you did it early, it's also wrong. Because this is the carbon where all the reactions happening, if that makes sense. It has to be the two carbons, they're opposite. Okay. And when we do this, what I said before was we don't do an electrophilic addition reaction because this reduces the stability of the benzene, which has clearly happened here because we've not got the delocalized ring. So what happens is the electrons from the hydrogen actually dissociate from the hydrogen and both go inwards towards the benzene ring. And this therefore reforms our benzene ring here, releases the hydrogen, which is here, and forms our nitrobenzene. So I said that I was going to explain why sulfuric acid is reformed. Well, this hydrogen that is released here will react with our hydrogen sulfates here to reform H2SO4, therefore meaning H2SO4 acts as a catalyst. Similarly then, we need to know about Friedel-Crafts acylation. So this forms phenyl ketone, a phenyl ketone should I say. The reagent is RCO+, so I'll just draw that here so you can visualize it. Because the carbon's got one less bond, it's positively charged, and this is the positive charge that allows it to act as a nucleophile. And the reagent, well, I've just said that, and the condition for this reaction is heat and reflux. Again, we need to know the reaction for forming the reagent, and this is an acyl chloride plus AlCl3, which reacts to form our reagent plus AlCl4 minus. What we need to know is that AlCl3, just like the H2SO4 earlier, is reformed as the lost H plus from the benzene reacts with the AlCl4, therefore forming HCl plus AlCl3. Finally then, a risk of benzene is it causes cancer. So that's just how science works, answer in case it's asked. That's all you really need to know about benzene itself. Within A means there's a little bit more you need to know about its basic properties and nitrobenzenes, but that's all fairly simple stuff.